I don't know if this is intentional or not, but I feel like this talk is a perfect successor to the previous talk. I don't know how many people were here before lunch with Jonas's talk, um, but Jonas essentially went through all the different ways that you can have kind of cross domain compromises within a forest. And this is kind of a very similar idea, just with Entra, right? So my name is Daniel. I go by Hot Nups on socials. I've been with Spectrops for about 5 years, and I've been researching this kind of, I don't know, this subcategory of Entra for a few months now. And so what I'm going to be sharing is just some of the initial findings from that research, and hopefully inspire you to maybe do some of this research along with me. So as I mentioned, effectively, this is the crux. This is like what I've been caring about. And what it is if there are two domains that belong to the same Entra tenant, what are what are our attacks, right? What are these arrows, these red arrows? What are those? Like how many do exist? Like if I compromise domain A, is that a guarantee that there's a compromise to domain B, et cetera, et cetera? And it turns out this is a very worthwhile thing to care about, in my opinion, because I grabbed I went on one of those investor relations websites and downloaded the websites for the top 100 Fortune 100 companies, right? I do not think this is accurate, but I couldn't be bothered to fix it. But so they say it's 77 of the top Fortune 100 companies use Entra. I think that's higher, but it also doesn't matter because that's not the point I'm trying to make. Of those 77 tenants, there are 7,708 domains that belong to those tenants collectively, which means we're averaging right about 100 domains per tenant. Now, not all of them are going to be like real, like physical on-premises domains, but that kind of highlights the point that this is a huge attack surface, right? So the median number between all of these that we collected was 57 domains. And I wanted to put a real world example of like an actual company up here, but I was advised not to. So here's what you can do. Here's what you can do. Go to AAD internals/OSINT and just pick a company, pick any company, and you could see the domains that are associated with them. And we care about that because once again, like for a mergers and acquisition standpoint, let's say we buy out a small company. And of course, we're going to guard our core domain, like our company.com domain. But what about this small company what we just bought? If that domain gets compromised and it's in the same Entra tenant, what does that mean for us, right? And so the name of this talk was kind of a play on a previous talk that was given 5 or 6 years ago by Will and Lee. That was breaking forest trusts, right? It was the forest is not a security boundary, right? And let's just say for the sake of this talk, Microsoft considers the forest a security boundary, with the caveat that, there's like coercion primitives that you can do and whatnot. In the sense of a forest, Microsoft actually explicitly plans out trusts, right? They have this idea of inter-realm trusts and interforest trusts, the interdomain trust account. So this is like a mechanical thing that's accounted for. However, in Entra, it's much more loose because the idea is that the tenant itself is a trust boundary, and then you have all these what they call like custom domains, and so they're it's not intuitive because as a sysadmin you might just say, well, like these are like physical on-premises domains. Of course they're separate. What does it matter if I join them to my Entra tenant? And that's really what we're trying to break, right? And then from this theory of attacks, we have to think of it in terms from first from the cloud down. So let's consider all the attacks that can happen from the Entra tenant down to on-premises, right? And let's call that set A. Then we're going to take a set of attacks that go from domain A to the tenant down to domain B. If that's set B, then set B is a subset of set A. So we can start our research by saying, well, what's possible from the cloud? And then saying, okay, well, that's possible from the cloud. What's possible cross-domain, right? So that was kind of the approach. So the way that this trust is established between domains is primarily through not some explicit defined protocol, but through a program called Entra Connect Sync. And you might have heard this as like 80 Connect Sync. They just rebranded it. But Entra Connect Sync is the mechanism for essentially replicating users and groups and all those things from on-premises up to cloud and vice versa, right? I like to think of it as kind of like a conflict resolver in the sense that the interconnect sync is supposed to be this single source of truth. So you ingest properties from on-prem, you ingest properties from the cloud. It detects if anything is inconsistent with each other, resolves it, and pushes out the changes, right? And so if we were to look at Entra Connect Sync, this is kind of what it would look like under the hood. Like if we were to open it up, is that you have, we're going to get into the metaverse in a second, but you have this idea of a metaverse, and then you could tell like a software engineer wrote this because they made it like super abstract and like plug and playable, right? So in theory, it doesn't have any concept of Active Directory and Entra. They call them connector spaces. So any directory can have these connector spaces that ingest properties, and it does all these things based on rules, and then it says, okay, I'm going to push out these changes. What we care about though is these two principles here. The one in green that starts with MSOL. MSOL is actually the branding name before Azure AD, which is Microsoft Online. So once again, you could do a whole talk on how renaming things causes confusion with Microsoft. But this MSOL account is the on-premises account that does all the syncing. And then the sync underscore random is the Entra account that does all the syncing on that end. So what this kind of looks like in a simple picture, just to keep in your head, is that on premises we have MSOL down here in the green, cloud is gray, right? And this Entra Connect is in control of both of these principles, right? Now here's kind of the one thing I want you to remember is that if we have multiple Active Directory on-premises, ADDS systems, they are going to have their own individual sync accounts that go up into Entra, but these sync accounts are identical. They're identical in every single way, except for like the name, but their permissions are identical, right? And there's all these things that those sync accounts can sync up. So just to prove that I can do some reverse engineering, which is, it's DNSpy, so like it's light, right? This list that you surely cannot read on the right is the start of all the properties that get synced up into Entra, right? So that's to say that there's these accounts that exist cross-domain that can write to any other principal, right? And before we get too far, I'm obliged to say this. Microsoft specifically says that the custom domains within a tenant are not a security boundary, right? And so kind of like how Jonas approached it previously, I kind of think of this as almost like a math proof, right? It's a math proof in the sense that Microsoft says this is possible, and then it's up to us to say, okay, well, how is this possible? And in what ways is this possible, right? So they're already saying this not a security boundary. So really what I'm telling you is nothing to be fixed by Microsoft. It's just we're trying to find all these ways to do it, right? And so what Microsoft says you should do is for every forest, for every domain you have, so your average median is 57 domains for the top Fortune 100 companies. You're going to connect them. You're going to build a VPN that connects all 57 together, and you're going to have one sync server that manages all 57 of them, and they all get into the same metaverse, and then that has one sync account that goes out. That's what Microsoft wants you to do. And this image, by the way, is from their documentation. This image is also from their documentation. This is what they don't want you to do. And this is kind of what everyone does, which is, okay, so like who's gonna set up a network for all their, I would actually, as a consultant, I would say that's almost worse. It's almost worse to do this because that is an incredible tier 0 asset right there in the middle. So they say, please don't do this, big red X. Please don't have multiple sync servers, right? And then at the end of this long paragraph about how you shouldn't do this, they say, while it's not supported, it still works, right? It still works. So it's like wink, like I kind of think this is to maybe mitigate some of like the things I'm going to be talking about, or to say like, or to kind of wash their hands of it and say, well, we told you not to do it. Um, but yeah, the idea is that this is not supported. So, but the caveat here too is that this only takes 3 minutes to set up, right? You install interconnect sync on a domain. It's super easy. It's super easy to get working. So what would you rather do? Would you rather install an interconnect sync agent in every domain, or do this incredibly complex networking setup that potentially has horrible security side effects, right? And so to understand the rest of this talk, I'm going to talk a little bit about the metaverse. And I know it's kind of late in the day, so I put a warning here. If you're going to tune out, this is probably maybe a good time to tune out, and then I'll tell you when to tune back in. But this diagram is from a blog post that I put out in December, which is kind of a representation of this metaverse, right? So the idea being that there's these actual agents, kind of like SharpHound, that go out and collect data from on-premises and Entra, and they aggregate them into what they call a connector space. And then that connector space does what's called a projection into the metaverse. The metaverse being the single source of truth. And so if there's properties that we care about from the cloud, they get pushed onto this metaverse user. And if there's properties on premises, they get projected onto this metaverse user. And then there's rules about where they go, right? And so we kind of need to understand how rules work. And for what we care about, the primary thing that we care about is how joining works. How do, if I go back, how do these users in the connector space, how do they get tied up to the things in the metaverse? How do they get linked? And then scoping, filter, and transformations are going to be pretty self-explanatory. But if we go into the join rules, what happens is when we first start, it's going to iterate through each rule, each join rule, until a match is made. So if you were to open up all the sync rules for an interconnect sync agent, there's going to be a whole bunch of rules and there's going to be priorities for them. So it's going to go priority 1, what do you got? Priority 2, what do you got? And if there's more than one match from a connector space to the metaverse, it's going to throw an error being like, you have a collision, you need to fix that. I'm not going to fix that for you, right? So really what that kind of looks like is this. And this is a particular example. So this is a concrete rule, not just like abstractions from interconnect sync. So there is a particular rule in interconnect sync where it's going to take the object GUID of a user. So that's very unique. And it's going to base64 encode it. And that's going to be the ID of the metaverse user, right? And that's how it's going to join. So when it ingests all these users, if there's a new user from Active Directory, it's going to look at the object ID and it's going to say, hey, is there a user in the metaverse that has the base64 encoded version of this? If not, I'm going to create one, right? And so that's how this link is made. And it's actually made in an MS SQL database. And at that part, I stopped reverse engineering. But I do think that's worth examining more, right? So what we see here, you probably can't read this, but what I want you to note is there's a link type at the bottom saying provision. So there's 2 types. One is provision, one is join. Provision means if it doesn't exist, I'm going to create it, right? And that matters because when we go the other way from cloud down, that does not exist. It's not going to create a user on premises, right? But it also says I want to join based on the object GUID or this MSDS consistency GUID. So there's actually 2 properties that it'll try to join to, right? And then, so that rule kind of highlights this first arrow. And then this rule is also going to be a provision rule. So it's going to say, all right, now that I've ingested everything into the metaverse, let's do our outbound processing. And the outbound processing says, okay, for Azure Active Directory, aka Entra, if that user doesn't exist, I'm actually going to create that user in Entra. And the principle that does that is that sync account that I highlighted earlier, where every single one on every Entra Connect Sync installation is the same, right? Has the same permissions. All right, so we just highlighted one sync cycle. Now, if we do it again, that Entra ID user is now going to exist in Entra. And when we import those users, it's going to go, oh, here's an Entra user. I'm going to look at the source anchor that exactly matches the source anchor in my metaverse. I'm going to tie them together. So now we have both representations of this user tied together to the metaverse user, okay? And here's the exact rule that does that. So, so that's how joining works in a nutshell. And then scoping is pretty self-explanatory. It's really a rule that says these conditions have to be satisfied for this operation to work, right? And the important part here is that scoping happens both at ingest and at outbound, right? So scoping can happen before it gets projected into the metaverse, but it could also happen as it's writing properties outbound, right? All right. And then lastly, transformations, just kind of covering for completeness. This is just to say that like properties aren't always one-to-one. They actually have built-in VBA scripts. So you could say like, for example, base64 encoding your object GUID, right? You could literally say, oh, well, I'm going to take your object GUID, I'm going to base64 encode it, and I'm going to set it as property name blah, right? Okay, that's it. That's hopefully you have a sense. That's the driest part. So we made it. All right, so a lot of properties go up, right? And for all intents and purposes, it's intended to go up, right? So everything from on-premises goes up into Entra because on-premises Active Directory is supposed to be our source of truth. However, there is one property that goes down from Entra ID to on-premises, and that is the MSDS key credential link. And if that sounds familiar, it's been talked about quite a bit before. It was talked about as far as I'm aware of, 6 years ago at Black Hat Europe by Michael Grafnatter, and then Alad did a blog post about shadow credentials, and then even recently as last November, Durkan did a talk about how to abuse this from cloud to on-prem. And if you're not familiar with this property, essentially what it is it's a public key that gets written to your user, such that if you have the private key, you can authenticate as that user on premises. So it's supposed to be like a PK init primitive for a variant of Windows Hello for Business, right? So in theory, if you could write a public key, if you could generate a key pair and write the public key to this property, you can authenticate as that user on premises, right? And the way that looks is here's the exact rule that we're examining, and you'll see that, well, I can see it. I don't know if you could see it. But it's in the metaverse, it's called a device key. And then it's going to get written down to MSDS key credential link. So you might be wondering, okay, well, what does it take to write this Windows Hello for Business key on a user, right? And it's a little more complicated or a little more convoluted than one would hope, because you need recent MFA. And when I say recent, I mean within 10 minutes. And you need a token for this particular device registration service. So typically this means that you would have to have the plain text password of a user and some sort of two-factor authentication. Now, I think there's a lot to be explored in this particular part of the attack. Like if we look at like certificate-based authentication that can accounts for two-factor, or new ways to add authenticators, then we can kind of ease this burden. But for this case right now, let's just say we control the plain text password, we control two-factor. So this is what it would look like. Let's say we compromise green domain, right? We're DA, we own it completely. And maybe that's, small vendor dot blah, blah, blah dot XYZ. And that belongs to the same tenant as megacorporation.com, right? And let's say there's a user that we care about in megacorporation.com that is synced up to the tenant, which is a fair assumption, right? If they're doing any kind of hybrid identity, like with Entra Connect. So here's what we can do. With our sync account that we compromised on our domain, on our green domain, we could change the password of that user, right? And you might be thinking, well, isn't that it? Isn't that game over? Not really, because remember, that password doesn't go down. All you did was change the password for the Entra user. You didn't change the password on premises. But what you can do at that point is register MFA if there's not one already. So let's say we just narrowed our kind of attack surface a bit. Let's say we targeted a user that doesn't have MFA set. Let's say it's a service account or some sort of automation account that users typically don't log into. I think that's a fair assumption. So we set the password, we register an MFA, and then we add our Windows Hello for Business key. We essentially, and that's the MSDS key credentialing. So at this point, we push our key up into Entra, and then what happens is the next time that sync cycle runs, that key is going to get written down to that user on premises, right? And then we can authenticate as that user if we have line of sight to that domain controller. So that's the other caveat here, is that attacker has to have line of sight to the domain controller and the red domain, right? So like maybe we fished our way in or something like that, but we want to privesc. So at that point, we have a kind of an idea of what we have here. Our attack surface is essentially synced users in any of the domains in the tenant that don't have MFA set, right? We can say if we have a reasonable suspicion that you don't have MFA, we can change your password, register MFA, take over your account. And that means we also don't need to know like the on-premises plaintext password, right? Now, if you're Microsoft, at this point, I mean, I don't know. I haven't talked with anyone from Microsoft. And if you are from Microsoft, I would love to chat about this. But if I was them, this is what I'd be saying. Well, we recommended that you only use one sync server, right? Wink. It still works without it. And the second thing I'd say is you're not supposed to sync privileged accounts, right? That's a very common thing we'd say, even in our summaries and our reports. We'd be like, you synced a privileged account, don't do that, right? If there's a Bloodhound path to tier 0, you probably shouldn't be syncing that account. To which I'd reply, well, let's consider this. All right, so we're going back to like this connector space metaverse example, right? And at this point, we have a user that's projected into the metaverse, but there exists some rules by default that prevent that user from being provisioned out into Entra, right? And there's one in particular called cloud filtered. And there's Microsoft documentation that recommends you use this particular property to not sync users, right? And what this VBA says is, all right, here's my long list. If your username starts with KRBTGT, if your username starts with support, blah, 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 if your username, so on and so forth, if any of these evaluations are true, you are going to exist in the metaverse, but I will never provision you into Entra, right? So you're just going to sit there. You're going to sit there and do nothing. And this is exactly what the rule looks like. So this is the rule to write users out into Entra. It's going to say, all right, are you cloud filtered? Are you, what is it else? Is your source anchor not null? Is your account disabled? If any of these are true, I'm not going to provision you, right? So what can we do as an attacker? Remember that the next time the sync engine is going to run, it's going to try to match a user with the source anchor to the user in the metaverse. So if we compromise a domain, we own a sync account, we have the ability to create a user that matches the source anchor of that user in the metaverse, right? And if we can do that, we can then write a Windows Hello for Business key to that user, and then that Windows Hello for Business key will get synced down to that particular user that we care about, right? So we just went from our attack surface, I mean, I can't definitively say how much bigger it got, probably not a lot, but our attack surface went from synced users without client or without MFA to metaverse users without MFA. And now this is really up to the client environment to how extensively they use things like cloud filtered, right? If they decide, all right, well, if it's a sensitive account, I'm going to cloud filter it, then you're in luck, right? Because you can just fake this user up in Entra and then force that link to happen and set your credentials down, right? All right, so at this point, I'm going to do a demo. And I just want to give some credit because this demo, I didn't really write any custom tooling for this. All of the heavy lifting has already been done by Dr. Nestori Cinema. I hope I pronounced that right. And Dirkan Malama. And then the C2 is Mythic, and that's done by Cody. So I really had to do very little custom work for this. And hopefully this is big enough. I know that's kind of hard to see. So I'm going to walk through this just to make it feel concrete and like a real thing that I'm not just making up in my head, right? All right, so here's the scenario. We have an agent that is red up here that is privileged, and let's call it, it's the ADFS domain. And then we have an unprivileged agent in SCCM. And what we want to do is we want to get domain admin in the SCCM domain, right? So what we're going to do is we are going to get our sync credentials of our synced user. So this comes from AAD internals, and you'll see here that we have a username and password that gets dumped out. So with that, with our sync credentials, we are going to get an access token for that particular sync account. And this is the sync account that I mentioned, remember, that has the exact same permissions across multiple domains, right? So this is kind of the linchpin of why this works, is because they're not scoped. It's not like the sync account for domain A can only write to domain A users, right? So we get our token, and then I like how I edited this to be super fast in some ways and slow in others. We have our source anchor, right? So we're going to take the object ID of our target and we're going to convert it to a source anchor. And then we're going to set, this is from AD internals. There's a commandlet called set Azure AD object. And what it's doing is it's using that sync API that the Entra Connect sync users to create users, to modify users, etc. Right? So we're going to use that same API to correctly this time to set our account, create a new account with our target source anchor, and then we're going to set a password. And that password, all it's doing is it's hashing it, encrypting it, and sending it up for like password hash sync, right? And remember, we could do this for any user for any of the domains within the tenant. And we just have to provide our source anchor. And we can just pick a plain text password. So I just pick password. Okay. And then the next thing we got to do, this whole step right here is just the process of registering our Windows Hello for Business key. This has been documented pretty well, so I'm not going to get into it too much. And also there is I do have a blog post documenting this particular step. So if you want to know like the exact commands that we run, that's also on that blog post. But really what we're doing is we're setting up our two-factor. Remember, this is a brand new user we created, so there's not going to be two-factor registered on this user. If we identify any partially synced user, it's not going to exist in the cloud, so we can hijack that user, right? And then we're going to steal our refresh token, and we're going to get a PRT. The reason why we need a PRT is because you need a PRT to register your Windows Hello for Business key. So with a Windows Hello for Business key, it's implied that you're tying it to a particular device. And to do that, you need a PRT to get that token with a claim, like a device ID claim, right? Once again, really not the intended like takeaway of the talk, but I did want to make this like a concrete walkthrough that you could use as like a red teamer, right? So we got our PRT and our session key. And this part right here is the important part. This is us saying, I'm going to enrich it. And I want to add this NGC MFA claim so that the device registration service knows that, and there's going to be a timestamp on it. The device registration service is going to check if that MFA claim is recent within the past 10 minutes, and it's going to complain otherwise. So we registered our Windows Hello for Business key. And this is something you would not see as an attacker, but something I wanted to highlight, which is when you run the next sync, you'll actually see those changes come in, right? So if you look at the import service or the import step right here, this Delta import, you'll see that there's two adds. There's one for the device that we just created. We created a fake device for this. And the other one is going to be the add of the Windows Hello for Business key right there, which you might not be able to read. But it says searchable device key. That's what it names it from Entra ID, and then it gets transformed to device key in the metaverse, right? So that's evidence that our key got pushed down. And then if we look at the export step, so there's import, sync, export is when we actually write out to the user property. You'll see that that export step got written to MSDS key credential link, right? And then this is something you would not see as an attacker. And then we switch over to RC2. So now that that key got written down, you might have to, as an attacker, you might have to wait up to 30 minutes for this to happen because you're not in control of that sync cycle. So by default, when you install Entra Connect Sync, it will sync every 30 minutes. Now, of course, you could change that, but you might have to wait. So as an attacker, you just, I don't know, go do something for 30 minutes. And the next thing we do is run Rubius. So remember, we set this public key on this user that we can authenticate to as. And so with that private key, we're going to create a PFX file, and we're going to use Rubius to ask for a TGT using that PK init function in it, right? So we have our private key, and now we're just going to ask for a TGT, and you'll see here that we got a TGT for this user that we targeted called AAD takeover test. Now this user is running as domain user, so this is effectively the completion of this PrivS, right? We got our ticket, and now we can authenticate as this privileged user, right? Yeah, and that is, yeah, that's all. So to prevent this, I didn't want to just come here and talk about how Microsoft is gonna the common design decisions that you make will lead you perpetually vulnerable, right? There are ways to prevent this. And the first that I'd recommend is you just want to make sure that you identify and are aware of all the partially synced users that are in your domains. And there's easy ways to do this. In fact, with the AAD Connect, they actually provide a bunch of very useful PowerShell commandlets to kind of interface with this metaverse system, right? On top of that, I have a couple scripts. I would not claim that they're well supported or even well developed, but they get the job done. That they're in my GitHub called EC Utilities. So that's Interconnect Utilities. And this one does get EC domain user partially synced. All it's going to do, it's going to go through all the users in the metaverse and see if it has a connector to Entra ID. And if it doesn't, it's going to flag it as partially synced. So as an administrator, you could look at this and go, okay, well, here's all my partially synced users. Do any of them have a path to tier 0? And if so, maybe put an alert on that. Maybe say, okay, well, if anyone ever writes MSDS, put a SACL on MSDS key credential link or something like that, right? The other thing I want to note too is that MSOL account that's responsible for syncing is also responsible for writing these keys down. So that's a very privileged account, right? It can do a DC sync, and it can write creds to any user in the user's directory. Let me rephrase. It has the write MSDS key credentialing property on the user's OU, which means any user in the user's OU that doesn't have inheritance disabled will be vulnerable to this. Having that said, there are privileged users, like anyone that belongs to domain admins, will have that inheritance disabled, which means that MSOL account cannot write to it. And those users are protected. So if this is something you are concerned about, which I think if you run a large organization, I think you should be, note which users in your domain have a path to tier 0 that don't have this admin SD holder property, right? And that'll give you a good idea of who's vulnerable to this in general. So that's how you prevent it. And then there's detection. And I think detection for this particular attack is pretty easy because you can simply say, all right, in the metaverse, you have a property called cloud filtered equals true, right? if you're connected to an Entra connector, something went horribly wrong because you're not supposed to be provisioned into Entra. So you could say, all right, well, uh, if those two properties exist, that's a pretty good signal to noise ratio that someone's doing something funky, right? So there's a PowerShell command called get ECU domain users hijacked, which will look for exactly that. And you could just run that periodically and hopefully nothing ever shows up, right? So that's prevention and detection. The last slide that I want to leave you with is just kind of a thought experiment, not a thought experiment, but just something to take away, which is there's a lot more to do here, right? I've been looking at this for a while, and we've identified some really fun things. The places I want to go next are like, there's this whole list of properties. There's a lot of Office 365 properties that are interesting. There's a lot of places where I think logic bugs could be introduced in Entra Connect that could offer possible priv-esque primitives. And then remember that on top of all the things that Microsoft has warned against so far in the documentation, they still want you to go to Entra Connect Cloud Sync or Azure Active Directory Cloud Sync, depending on how old the documentation is, which is a cloud-based model of exactly this. So with Entra Connect Sync, there's actually quite a bit of CPU cycles that are used by doing all this diffing and checking and ingesting. And Entra Connect Cloud Sync kind of does all that in the cloud. So you run like essentially a simple connector on premises, you install it on premises, and it's going to do all that on cloud, which means all of those sync rules are processed in the cloud. So even if you switch over to Entra Connect Cloud Sync, that boundary between on-premises and Entra ID degrades even further, right? So I think it just becomes even more simple to prove out this compromise of domain A equals compromise of domain B. So these are all things that I look forward to investigating over the next few months, and hopefully you do too. But really that's about it. I think I kind of sped through that. So does anyone have any questions? Yeah, hold on one second.
When that Windows Hello for Business key is written, is there a log event associated with that?
Ooh, that's a good question. So the question was, I don't have to, yeah, but Mike. Yeah, I don't know. That's a good question. I haven't looked, but I'm also not a defender. So like, I'm usually happy if I pull off the attack. You're lucky you got prevention and detection. I felt like that was me going out of my way. So I don't know. That's a good question. All right, thanks, Joe. So.